Welcome back to the Breaking Math Podcast. My name is Gabriel Hesch. I am your host, and we are here to talk about the mysteries of mathematics and how it helps us to understand the world. But we'll be interviewing the author of Math for English Majors. This is in the fine tradition of physics for poets, but it's mathematics for English majors. And we'll be joined by the author, Ben Orlin. This is our third time interviewing Mr. Orlin. And joining us today, as always, we have my awesome co-host, Autumn Fan-F. Autumn, how are you today?
I'm well. How are you doing?
Doing fantastic. And I see Ben is already in the room. Ben, thank you for joining us. Pleasure to have you here.
Yeah, thanks so much, Gabe and Autumn and everybody for welcoming me to the Breaking Room.
Breaking room. Yeah, I like that. I'll use that term here.
Yeah.
Today we're diving into a book that takes a fresh and witty approach to bridging the gap between numbers and words. Our guest is none other than our very dear friend Ben Orlin, an educator, cartoonist, and author whose work makes math accessible and often hilarious for readers of all stripes. You may know Ben from his previous books, Math with Bad Drawings and Change is the Only Constant. But today we're talking about his latest work, Math for English Majors. It's a book that's very much a storytelling and language as it is about mathematics. Ben takes the readers on a journey where literary lovers can discover the hidden beauty and logic behind math, while math enthusiasts can see how their world intersects with language and literature. Math for English Majors challenges the notion that math is all about cold calculations. Instead, it shows the same creativity and narrative flow that we find in great writing, also in mathematics. Whether you've ever felt like a word person or a numbers person, Ben's book is here to show you that these two categories are more fluid and more fun than you might think. We're excited to chat with Ben about the inspiration behind his book, how he turns math concepts into engaging stories, and why he believes that math can be for everyone, even those who thought they'd left it behind in high school. So grab your favorite book or maybe your calculator and join us as we delve into Math for English Majors with Ben Orlin. Let's get started.
The Labor Day weekend sale is on at Tanger Outlets. Score up to 70% off at top brands like Nike Factory Store, Crocs, J. Crew Factory, Gap Outlet, and so many more. Refresh your wardrobe with the latest arrivals for less from all your favorite brands this Labor Day weekend. Tanger Outlets, always on trend, always on sale. Plan your trip at Tanger.com.
We all belong outside. We're drawn to nature, whether it's the recorded sounds of the ocean we doze off to, or the succulents that adorn our homes. Nature makes all of our lives, well, better. Despite all this, we often go about our busy lives removed from it. But the outdoors is closer than we realize. With AllTrails, you can discover trails nearby and explore confidently. With offline maps and on-trail navigation, download the free app today and make the most of your summer with AllTrails.
I'd love for you to, if you could, do a little introduction and tell us about your blog as well as your other books and what you've been up to recently.
Yeah, no, thanks, Gabe. I mean, what I do for a living is I sit down at my desk and I grab Sharpies and blank paper and I draw little stick figures making jokes about math. And that feels like that shouldn't be a job, or like maybe there should be one person who has that job, Randall Monroe. But turns out he's so good at it that it created this whole category of human beings, and of which I am one. So I get to write about math and ideas I find exciting, and how to learn math and how to teach math, and the parts of math that need more of a spotlight, deserve a little more attention. And so I've been doing that on my blog for 10 years now, Math with Bad Drawings, and this is my fourth book coming out in September. And so the books have been about sort of each taking a slightly different angle on math, and this one feels in some ways the most different from the other three. It's about math as a language and about going after the parts of math that have kind of the least glory, the ones that people grumble about the most. Those are the ones I most wanted to give them some celebration, a chance to shine and show us that they're actually really weird and quirky and cool.
Awesome. I might ask you real quick with this book in particular. I know you said earlier you have Math with Bad Drawings, which I think takes a look at, would you say, a general math curriculum from, kindergarten through, there's even some college in there as well. Does your first book?
I mean, that first book, Math with Bad Drawings, it's about different applications of math, right? To put it as blandly as possible. To put it less blandly, it's about all the places that math pokes out in the world, places you wouldn't expect to find it. So places like lottery tickets and analyzing lottery tickets through thinking about expected value, or looking at the geometry of the Death Star, or looking at scaling factors as organisms grow, and so why an ant, which is teeny tiny, like doesn't have any reason to fear falling from heights, but has every reason to fear water droplets. Whereas we are kind of the opposite. If you drop me off a building, that's very scary to me. If you drop rain on me, not so scary. And it's really just about size. It's not anything. It's not anything special about me versus the ant, other than how big we are. Anyway, so that's math with bad drawings. A lot of that stuff is nowhere in the curriculum. Actually, it's like what I wanted to do is I wanted to gather all these cool tidbits and pieces that just like aren't there in school math. School math is doing something else, and so it doesn't hit all those fun ideas. And then this book, actually, which is my fourth, I almost wanted to do the opposite. I wanted to, not that I didn't want to have fun ideas, I did, but what I want to do is I wanted to reconcile the fact that you can have all these fun conversations about math and be like, oh, look at fractals, these are so fun. Look at the coastline of Britain. Look at look at chaos theory. Look at triangles in roller coaster architecture, and that's all very cool. But there's something there in school. There's something important happening when you sit down and solve equations, or when you sit down and calculate. So it's not the glamorous part of math. It's the part that gets kind of drummed into you in school, and it's not the part that we often, math popularizers like me, are often celebrating. But there's got to be something going on there. And I think to expert mathematicians, it's almost invisible. It's sort of like, oh yeah, we just do that on the side. That's our bookkeeping. So they don't want to talk about it, and kids don't want to talk about it because it's mystifying and confusing and full of weird notation. And so I was like, okay, how can I dig into this space, exactly the stuff that's taught every day in school, and how do we see that with fresh eyes?
Nice, awesome. And of course, your second book is on calculus, and it's calculus with cartoons. Obviously, that's another catchy name, of course. The reason why I bring up the curriculum specifically, I don't mean to dwell too much on this, but the Breaking Math podcast is very, very centric with electrical engineering because my degrees are in electrical engineering, which means that we are obsessed with things like Shannon's information theory. How familiar are you with Shannon's information theory and entropy?
A little bit. I could give the definition of Shannon entropy.
Awesome.
You already have it though, so you don't need it from me.
It's all good, man. It's all good. But like, when I do the podcast, it's forced me to, how do I explain this? Learn other areas of mathematics and how they're used in science and understanding the world in ways that I'm not used to doing. And I kind of feel like, I don't know how much of a video gamer you are, but in an RPG, you've got this skill tree, right? And with the skill tree, you decide, what you're going to work on, whether it's magic or defense or quick attacks or whatever, and there's so many ways to play it, and I feel like I'm leveling up on my math skill tree as part of this podcast. But the purpose of this podcast is to have great conversations with other people over the language of math in an accessible way. That brings us back to why I was talking about what your books go over and what people can expect with them. Just for that reason. This last year, I've had to really delve into statistics as we tried to tackle machine learning, and that's not usually a field that I enjoy much, but yeah, we've gotten a lot into that. So anyways,
yeah, that makes sense. No, it's interesting to hear you talk about it, because we have this one way of organizing that's very familiar, or even variations on this one way of organizing math that's very familiar from school, and that's like a nice way to organize math. But there's lots of other ways to organize math to chart your path through the ideas. It doesn't have to be that, like, okay, you do pre-algebra and then you do algebra and then you do these years of themed courses and then you get to college and there's sort of this little obstacle course you have to follow through the undergraduate degree. There's so many other ways to organize and think about math. And so right, for a medium like audio, you get to do it's a different organization that you're presenting here.
Yeah. Do you know, I've heard that in Great Britain or in other places, they don't necessarily teach it in the same order. I've heard that you might learn a little bit of calculus, much earlier than we do here. Like it's sprinkled in here and there as needed. And I number one, I've only heard that as a rumor. Number two, I don't know if there's a more effective way. Is it better to do it the U.S. way, or is it better to do it that way, where you've got a broader knowledge, even if not as deep? Is there any truth to that rumor I've heard?
Yeah, I can confirm the rumor. That is true. GCSE, which is kind of the 10th grade, 9th and 10th grade course in the UK, typically doesn't cover any calculus. Okay. But if you do there are sort of like slightly enriched versions of that. My knowledge is a few years out of date on this, but that will cover calculus. And then the A level, which is like the junior senior year curriculum, does lots of calculus, but also with lots of other stuff mixed in. And doesn't, the A level curriculum I didn't teach, so I don't know it as well. I taught the IB, but the IB is the same. So, where there's some calculus and then a mix of other topics. The U.S. is weird in this sense. I don't know exactly the history of why the U.S. does these annual themed courses where it's like, all right, it's geometry year, all geometry all the time for a year. Like, okay, it's calculus year. We're doing calculus, nothing but calculus from start to finish. Other countries find that weird. Mathematicians from other countries think that's like weirdly single-minded and narrow. I think it works fine. I think, I like the unity of the year, but it's also... It's definitely not necessary because there's dozens of countries out there doing it differently.
Yeah, I hear you. That's quite something to reflect on. I think that it'd be easier to answer the question, why are we doing this, when you have more of an idea of how everything, how everything, how everything relates to each other. So I think there's some value to doing it that way. So, okay, awesome.
I have one question for you that readers are going to be wondering when they see the title of the book. Is it meant for mathematicians or is it meant for people who are English majors? I know that you have a very long history of combining the two, and where did that start?
Yeah, it's a very good question. I'm gonna wind up giving a longer answer than would probably be ideal. But yeah, so one of my favorite pieces of feedback I've ever gotten on one of my books, it's like an Amazon review or a Goodreads review, which I don't tend to read, but someone pointed it out to me, where it described my books as basically like Pixar movies in structure or in approach. That like there's jokes there for the grown-ups, but then and grown-ups here, not literally grown-ups, but people who know the math already. But then the plot is there for the kids, it'll be new, and the kids being just like people to whom the math is new or surprising. Could be genuinely kids, could just be people who, didn't memorize everything they learned in secondary school math. So that's always been what I've liked doing as a writer, is kind of finding a way to finagle both audiences. I think for people who don't know math, my books are unusually accessible. I'm not going to claim that every page and every sentence in every book is like going to make sense to you immediately, because that's not how learning math works. But I think, I pride myself on really trying to make my books accessible. And the way I do it is not because I'm a genius at making things super clear. It's like I run it by people and they say, that doesn't make any sense. And then I fix it. It's like my editor, Becky, is great for this. Really bright, edits lots of pop science books. But if I give her a page of nonsense, she's like, that's a page of nonsense right there. Just much more politely than I would, but I can hear what she's saying. Anyway, so I've always tried to go for kind of the two audiences. I want the books to be novel and surprising and exciting to people who don't. I want them to be accessible to people who don't know the math. I want you to be able to walk in and not have to read it in this painstaking way and not have to feel like a math textbook. But I also want the book to be, if you do know math, which is most of the people who buy math books, probably a lot of the people who listen to this podcast, like I want it to have exciting new thoughts, bits of history and jokes and anecdotes and different ways of explaining things, or just little excursions that you might not have thought about before. And this book, I tried to write it that way. The original pitch for it was basically, do you guys know the book Eats, Shoots, and Leaves?
Yes.
I don't, actually.
Oh, okay. Do you want to, what's your familiarity with it, Autumn?
I've seen it a few times.
Yeah.
Not terribly in depth, but I've seen it.
Yeah. It's a delightful book. So yeah, the joke. So yeah, Eats, Shoots, and Leaves. It's a book about punctuation. Lynn Truss is the author, and it's just this delightful series of essays about the different punctuation marks in English. And the opening joke is Panda walks into a bar, has a meal, fires a gun in the air, and then walks out. And people are like, what was that panda doing? That's crazy. And then they see in there's a book it left behind where it says Panda eats, shoots, and leaves. The point being that the commas anyway, so that's one of the there's I think she makes fun of the joke for not being all that funny, despite the fact that she put it on her cover. I think it's a good joke. Anyway, so my pitch was I wanted to do that for math. I wanted to do punctuation marks, but like I wanted to eat, shoots, and leaves, but talk about the history of the plus sign and talk about algebraic notation. And I tried to write that book, and actually that book isn't writable. And the reason is because if you don't know math pretty well already, you don't have any associations with those marks. Maybe plus and 7 you do, but a lot of the notation of math is just inscrutable. It's like worse than Sanskrit or something. It's like a language, not just that is an alphabet you don't know, but it's not even an alphabet. It connects to the ideas in a different way. And so it felt like one where I couldn't do my usual trick where I like sort of explain it for the novice audience, but then include some fun, other material for the more expert audience. It's like early on in writing the book, I was like, okay, I got to make a choice. Who am I writing this for? And I said, okay, I want to write this for the new people. And then weirdly, I got deep enough into it that I could step back and be like, this is a weird explanation. I'm talking about math in ways that I've actually never talked about it before. Just trying to animate the weird life behind the written language of math. Actually, like when I would explain it to math friends, friends who are mathematicians, they'd be like, huh, really? Like a variable is a pronoun? Okay. Like it's not how you think of a variable, but like, yeah, that's kind of right. A variable is a pronoun. It's it's a way of referring to a number without needing to say it by name. And it opens up a nice kind of linguistic approach to mathematics. Like that. The idea that plus isn't a verb. It's like, oh, it is because you add things. Like, well, no, in English, add is a verb, but plus isn't a verb. 2 plus 3, nobody's doing the plus. It's more like a preposition. 2 with 3. 2 and 3, conjunction maybe. Anyway, so I found myself like, despite choosing to go for the more novice audience, as an expert mathematician, I'll put expert in scare quotes, like I found myself a little surprised by what I came across. So I think the book does wind up, it really genuinely is written for English majors. My editor is an English major. My agent is an English major. I was really like, I did have some specific English majors in mind. But I think it actually is, it will be a little weird and surprising in the same way that when you really look closely at English and things you do naturally as an English speaker, you're like, what? Oh, wow, I never realized I was doing that. I think this book will give fluent speakers of math the same feeling about math.
Nice. I gotta say one thing real quick. Well, a couple things. You had mentioned an early draft or an early idea of this book about math symbols, and the inaccessibility would be that people don't know those symbols. As you said earlier, it's like strange Sanskrit, a bunch of symbols and Greek letters. You're like, I don't even know what this means. What's so funny is one of the books that we were just given, like we get more books a month than we know what to do with.
Oh,
one of the
books... Prince University Press just published a new one. Is this the one you're thinking of?
It might be the book on the history of all the symbols of math.
Yeah. It looks like a nice book. Yeah, I have the.
Yeah.
No,
but I was gonna say that would be an amazing book. Yeah.
Yeah, I've just skimmed through it. That's a really nice one. I mean, and that one, I think it looks like a lovely book from what I can tell. And they just took the opposite fork at that early fork in the road where I said, okay, I got to make this accessible to novices. I want to make this for people like my stepmom, who talks about how very bright lady. She ran into Algebra 1 and she she took it a year early or something and just like has hated math ever since. Just never made sense to her. She hasn't liked it since. But if you go the other way and you're like, okay, let's talk to people who actually know the math background, then you can get into that history. So I think that's I'm really glad that book is out there. Also glad I didn't accidentally write it. You never want to have two people writing the same book. They take a long time to write. If one person's writing it, then just let that person go write it.
Yeah.
Awesome. All I'm saying is that just like in hip hop albums, you get a really good mashups.
So, out of curiosity, how did you decide which concepts to include and what did you leave out? Or was there something that you really wanted to talk about that you left out?
Yeah, no, it's great. Your questions are going like right at exactly the process for this book. Weirdly, I wrote this book using the greedy algorithm. I went back and smoothed it out afterwards. I'd never written a book like this. I'm a very top-down thinker. So I like to outline and then say, okay, here are the 5 sections, and there will be the 3 chapters in each section. I really like to really plan it out like that. And this book, I tried that for a while. This book took much longer to write than my others. And so what I did, finally, what made the book work and start clicking was I sat down like, okay, what's the first thing I should tell you about math? And I wrote a chapter about counting, and about how to count is to come up with a system for naming numbers. Like that's what counting is. It's like you throw back to Genesis, right? And Adam's first move is to name the animals, right? Like that's counting. Counting is naming the numbers. It's giving the numbers names so we can talk about them. And we have a weird system for doing that. The one I start with in the book actually is in Welsh, where I was hiking in Wales and came across this little plaque that just listed the numbers in Old Welsh. And the one I love, it's in the teens. So you get 15 is kind of looks like 5 and 10 kind of. And then 16 is 15 and 1, which makes sense. That's 16. 17 is 15 and 2. But 18 is not 15 and 3. Like if you kind of translate the word literally, 18 is 2 nines. It's like double nines.
Why?
Because that's a great name for 18, right? Like, isn't that a cool name for 18? I don't know.
Why
Like,
not?
I wish I had, like you turn double nines, now you can vote. I don't know. I like double nines. And it's like a better, if you think about like what does 18 mean, right? The 8 is 8 and the teen is 10. That's the etymology. So like that's a weird way to call 18. Why would you call it 8 and 10? Like that's not the nicest. Like call it 9 and 9. That's a nicer way to think of 18, right? But of course you can't. It's actually really hard to learn to count in Welsh because you got to learn these wild names that are switching back and forth. It's much easier, right? Like Mandarin, as I understand, speak Mandarin, but it's even simpler than English in the sense, because it's sort of like you get to 10, and then it's 10-1, 10-2, 10-3, 10-4, and the more irregular your names are, the harder they are to learn. Anyway, so that's where I started. So I wrote that chapter about counting and naming numbers. And then it just kept going. I was like, I think the next one I ever sat down, I was like, that's a start, but we need to talk about negatives now. And I don't know why that was the thing I wanted to talk about first. Before we talk about fractions, before we talk about equations, negative numbers, we got to talk about that because I think that's something you encounter very young, and negatives embody a really different perspective on math. It's not about labeling things out there in the world. It's about, because you don't have -3 dogs. It's like not how the game works. So it's about negatives are about creating a system where things fit together nicely, where like opposite directions can be unified on one number line. Anyway, so I did that, and then I did that for like 40 chapters. They're all really short, and then I had to go back and kind of smooth it over.
The Labor Day weekend sale is on at Tanger Outlets. Score up to 70% off at top brands like Nike Factory Store, Crocs, J. Crew Factory, Gap Outlet, and so many more. Refresh your wardrobe with the latest arrivals for less from all your favorite brands this Labor Day weekend. Tanger Outlets, always on trend, always on sale. Plan your trip at Tanger.com.
People are driven by the search for better. But when it comes to hiring, the best way to search for a candidate isn't to search at all. Don't search, match with Indeed. The hiring process can be slow and overwhelming. Simplify hiring with Indeed. Indeed is your matching and hiring platform. With over 350 million global monthly visitors according to Indeed data, and a matching engine that helps you find quality candidates fast. Ditch the busy work. Use Indeed for scheduling, screening, and messaging so you can connect with candidates faster. Join more than 3.5 million businesses worldwide that use Indeed to hire great talent fast. Listeners of this show will get a $75 sponsored job credit to get your jobs more visibility at Indeed.com/PODKATZ12. That's Indeed.com/PODKATZ12. Terms and conditions apply.
But that was pretty much the book. So it was the greedy algorithm is the way I describe it. It's just like every day I would sit down and be like, all right, what is the next thing that I should write about? What's the next thing? If I was talking to a reader who's only ever going to read this about math, I've told them these 6 things. What's the next thing I should tell them? And it led me to places that like weren't the places I usually dwell in math. So it was a fun way to write it. What did I leave out? I think there was a chapter on functions that I cut. I think functions are a really potent idea and a notation that's really easily confused, but it was a little outside the kind of path that I'd been carving in this book. That was it. And also like everything else, right? Like any book, it's sort of like at the process of writing it, you discover there's 99 books that could go in here, and then it's about finding the one that does, the one that fits and coheres.
With that, do you have a favorite analogy or metaphor throughout the whole book?
Yeah, one of the ones I was very proud of, and actually I showed it to a linguist who also liked this metaphor, which made me feel good about it. Are you guys familiar with the term creolization?
No, I'm familiar with the language.
Oh, great. The Creole, right? Exactly. Yeah. Okay. So this is where Creole comes from. So it's right. I mean, it's a brutal history, but an interesting one. So what you get is a bunch of people thrown together. In the case of like Haitian Creole, we're talking about people who were abducted from their homes and brought across the Atlantic and enslaved. But that can happen in other settings too that are a little less cosmically horrible, where you get people thrown together who speak all different languages, but they're adults, and it's really hard to learn each other's languages as adults, and also like whose language would you learn anyway? And so what they do is you'll basically speak what's called a pidgin, not like the bird, but Pidgin, which is like it's not according to linguists, it's not really a full language. It's more like a phrase book. There's like a set of things you can say in the pidgin, and those are the things you can say. So it doesn't have the feature that English or Haitian Creole or American Sign Language or any full language has, which is it has a full grammar. You can sort of express almost any thought and generate sentences of like layered complexity. So this will come back to math in a moment. But so the way a pidgin becomes a Creole is that the next generation is born. And the human brain, for reasons I certainly don't understand, maybe some linguists do, is just thirsty for grammar. And so what kids will do is they'll hear that language. It's not a language. They'll hear that pidgin, and they will, just speaking amongst themselves, breathe life into it, and it will turn into a full language. So that's how a Creole develops, is the grammar is this structural richness brought by the next generation. And you go from something that's sort of simplistic and just a phrase book into something that's got this generative complexity. Anyway, so long metaphor, but that's my kind of pivot point in the book. The first half, 2/3 of it are essentially about arithmetic. So, what does it mean to count? What does it mean to talk about numbers between the counting numbers? What are our languages for doing that? The operations, when we add, when we subtract, when we take square roots, like what are we doing? What is that all about? And that gives you arithmetic, but arithmetic is almost more of a pidgin because you can only ever talk about specific numbers that way. You can say 7 and 2 make 9, or you can say 7 times 2 makes 14. I almost said 18. I don't know why I was talking about 18 earlier. You could say 7 times 2 makes 18. It would be a silly thing to say.
Technicalities.
Maybe we can find a. Is there a base in which it? Probably not. Anyway, but but you can only say so much. And if you want to say things like, when you multiply any two numbers, it doesn't matter whether you reverse the order, right? A times B is always B times A. You'll notice I have to slip into algebra. Algebra is the Creole. That's my metaphor, is that algebra takes this kind of list of numerical specifics and it turns it into this full language where you can talk about the language itself. You can talk about bigger patterns. You can talk about anything. You can't have literature in a pidgin. You can have literature in a Creole. And so anyway, that's a long metaphor. I've got to learn not to give 8-minute answers to questions.
I have to confess something real quick here. I did not read the entire book, and because I have 5 kids, I'm going to use the I have 5 kids cards so many times here. I read I read almost all of the last chapter, and I read a few random pages throughout the rest of it. Everything you just told us is utterly spectacularly fascinating, and I'm wondering, did you write what you wrote, what you just said in this book, or is this just facts that you knew that you're spitting bars here now that you're on the podcast?
that one. So that what I just recited there is possibly actually a wordier version, but is essentially the same idea as the introduction to the 3rd section. So the book is in 4 sections. The last one, I'm glad you turned straight to that one, because that one's the most browsable and kind of flip throughable. It's sort of it's like a phrase book of different like fun mathematical terms that I think can make cool everyday usage. But the first 2 sections are arithmetic. So it starts a section on numbers, and then a section which is called nouns, a section on arithmetic, which is called verbs, and then that section when you get to algebra and like algebraic thinking, which was really, that's what I was aiming at. That's really what the book was about, but it took a while to get there. I couldn't jump straight into that. It's at the start of that section called grammar is where you get the pidgin into Creole metaphor.
It's magnificent. And I only bring this up because in math of computation, and we get into Gödel, Escher, Bach, and I bring this up because this leads into a conversation on language. Our 5th episode of this podcast we ever did is called Word, where we sat down and we talked about the evolution of language with a colleague of ours who was a linguist. And it was fascinating. We then did a follow-up episode, I think probably 12 or 20 episodes later. Sorry, I forgot which one, called Language and Entropy. And it was literally about the continuing evolution of language and just about the concept of entropy itself. Now, it was, I think, proper linguists would probably not be a super big fan of that episode because this is folks who are not in the field pontificating about the field. Full disclosure. but still, you know what I mean? Like if concepts like entropy rule the universe, I'm sure there are ways in which entropy can be used to describe the evolution and change of language itself. This has been a continuing discussion, is like meaningful communication, communication systems, language, and entropy. It's fascinating stuff. Yeah. So I was wondering,
Yeah,
did you?
no, I love that stuff, and I'll say also in defense of people pontificating about things beyond their field.
Yes.
You know, it's sort of there's a trade-off here, because like I want math to be a communal possession. I don't want people to feel like math is something only for people with a doctorate in it. Particularly given that I don't have a doctorate, that would be a dangerous party line for me to espouse. But the price of that is like people don't always say things that are the experts would agree with, and like, you know what, that's okay when a communal possession, like, you know, you want people listening to the experts, but you also want them forming their own ideas, and some of the price of that is like, you know, maybe people are like a little more into the golden ratio than I think is strictly sensible, and like, you know, that's okay. That's what you get when math opens its doors a little wider.
Say tolerance for imperfection. Maybe we've reached the internet age of Aquarius, where suddenly there's this tolerance for imperfection. Yeah. Have you ever thought of discussing this book over a podcast with some linguists? I know a few.
That would be really fun. No, I would love to do that. I've been meaning to reach out to Gresham McCulloch, who I read her book Because Internet, and try to see if she would be so kind as to receive a copy. And the front cover blurb is David Crystal, another linguist whose books I've enjoyed.
Ben, one thing that I have to say is you don't need a PhD. You went to Yale.
Well, it's, you know, I try not to. My bachelor's degree is from Yale. I try not to trade too much on it, though. I'm just turned 37, and there's something I don't want to be too much like, if you're a 37-year-old who still needs to talk about what you were doing from ages 18 to 21. Like, I mean, one thing, if I'd been in the Olympics, that would be cool. Like, I think when Simone Biles is 37, I would encourage her to keep talking about what she did during 18 to 21. That was pretty cool stuff. I watched it on TV. For me, it wasn't. Yeah. Anyway, but thank you, Adam. I appreciate your vote of confidence in my pedigree.
Just knowing you long enough and seeing the evolution of your writing. And also knowing your partner as well, you know, just
right. Yes. Well, yes, my wife is what I would call a real mathematician. She's a research mathematician. So yes, right, as Autumn knows firsthand.
Yeah. So, you know, that does have some trade-off where you can just throw ideas.
Yeah, right. No, that's right. Yeah, and certainly, being married to a mathematician means that even though actually I managed to like squeeze through my bachelor's degree, never technically taking a real analysis course, it's easier over that kind of time scale than to pack it into a semester.
It's a trade-off.
Yeah.
Thanks. Okay, I want to ask, do you have a favorite part of chapter 4? Oh, and also let's explain what chapter 4 is for our listeners. It's where I think it's a great chapter to learn new language and to, I don't know, I felt really smart reading it. It gives you math terminologies, and it's like a thesaurus, comical usage of the math terminologies. Do you have any favorite parts of chapter 4?
Yeah. So the idea with that section, that fourth section of the book, is it sort of comes from this one moment at oral argument at the Supreme Court. So there was some lawyer, actually, I wish I should know the name of the lawyer, I don't know his name, who used the word orthogonal. He was speaking for the justice. This was 15 years ago, maybe 2010, 2011, and he used the word orthogonal, which as if you've done work with vectors, you know, it's a perpendicular, right? The inner product is 0. And two of the justices, it was Roberts and Scalia, who was alive and on the bench at the time, were like, what was that word you just used, orthogonal? And the lawyer's like, it means like unrelated, right? Because it was a word that was just kind of starting to creep, probably via tech circles from the math classroom into popular usage. And Roberts and Scalia, I think particularly Scalia, who was a real wordsmith, were like, ooh, orthogonal. I like that. They were like these very powerful Supreme Court justices just really into this mathematical word. Anyway, so that was my template for like, you know, there's more words. Obviously, exponential has taken off. Possibly at the beginning, it was even exponentially the way it took off. Logarithmic you hear, although often misused. Orthogonal's on the rise. Inflection point, which I'm not sure I love the way it gets used, but it's nice to hear a math word out in the wild. Anyway, so it was like, okay, let me go through math, take, I say maybe 80 or 100 terms in there, and just find ones that I think are really ripe for kind of fun usage out in the world, and then do a little definition that's accessible to someone who doesn't know the math, gives you a little context, and then a little cartoon showing how it could be used. One of my favorites in that section is brute force. There's a little subsection on like problem solving methods and heuristics and algorithms. And brute force, as any mathematician knows, is like, I don't have any clever ideas for how to solve this problem. I'm just going to try every single case. And so the example I give is two people in a parking lot full of sort of identical looking cars. And one of them is like, "Do you remember where we parked the rental car?" And the other one is like, "Nope. We're gonna have to brute force this. Just start walking around, pressing the key, and seeing what makes a noise."
The
I don't remember the exact
equivalent
phrasing.
of
Yeah.
the equivalent of that analogy for real life is for anyone who knows the UMass Amherst Smith College, Hampshire College area. The number of Subarus that you will go into the parking lot coming out of Whole Foods, you will mistakenly walk into another blue Subaru when you are coming out of the store or Trader Joe's.
Yeah, I believe that. Yeah, it was a Trader Joe's in Berkeley. I was borrowing my aunt's car, her silver Prius in Berkeley, California, in like 2010, and I came out and like I was like, oh no, I had to look for the bumper stickers. Was the only way I could identify which was the right silver Prius in the Berkeley, California parking lot.
Okay, I'm reading this right here. I found one that I like, but asymptotically. It's a really fun one. Really fun one. As eternity unfolds, you to describe an outcome that we don't necessarily reach, but to which we come progressively closer. I used that back in Algebra 1. Is that right? Something like that? That's a fun one. I don't know.
Yeah, Algebra 2 courses probably would tend to give some asymptotic behavior. Certainly
Right.
calculus, it's a really comes up a lot. Yeah, that's one that like really catches the eye. That one that one has already I think kind of slipped into the public imagination from the math textbook. There's a journal, like some kind of literary journal of translations, I think, that's called Asymptote. The idea being that when you translate a work of literature, you never quite, it's like it's never going to be the same as the original, right? Like to translate is to change, but a skilled translator can sort of approximate the experience of reading the original more and more closely in some kind of asymptotic way. You can never quite get there. It's never going to be the same, but you can get real close.
Okay, fair enough. I remember shortly after I got my degree, there was a colleague of mine and I were talking about dating apps and just like ambiguous signals that are just in the dating game all the time. And we used a lot of electrical engineering terminologies and concepts to describe that, like what's the signal-to-noise ratio with what you're picking up from her, and oh gosh, what were the other ones? That was the main one.
Noise is huge, right? Yeah, you're right. And again, going back to your interest in entropy and communication.
Yeah. Oh yeah. It was fun. So yeah. Cool book here. Cool book and cool thesaurus here on mathematical terms.
Out of curiosity, what did you find anything new when writing this book between math and literature?
It's a good question. This one, so every book I've written, I've found new things. There have been things that surprised me. The games book, which was my third book, is probably the one where it was the most novel. There was the least in that book that when I sat down to write it, I already knew. Because what it is, I sort of went out and searched for lots and lots of games. So there's like dozens and dozens of games, and they're from all different, some of them, a couple of them are games that were played in classrooms, but mostly they're sort of like little clever hobbyist games that people had shared on Board Game Geek, or ones that were getting passed around, or ones that kids were playing on schoolyards, but no one was really writing about. Anyway, so that one, there's tons of new stuff that I found writing it. This one, I was almost trying to rein in my desire for novelty, my interest in going and looking for new stuff, because I wanted to really laser focus on core mathematics. So like writing a chapter on addition, the hard part for me wasn't actually going out and finding new stuff to say about addition. It was like stopping myself, as you can hear the length of my answers, stopping myself from saying 45 minutes worth of stuff on addition when I'm just trying to say, I'm trying to do 800 words. I'm not trying to write a whole book on addition. So that said, right, I'm sure there was stuff that was new and surprising as I searched. I think one that it was a surprise that I found before writing the book actually, and then went into the book. But one of my favorite little discoveries was the word logoram. This is David Crystal, the linguist I mentioned. Yep. He has this book called The Disappearing Dictionary. And it's a collection of words from kind of around the British Isles that are fading from usage, like words that were just little colloquialisms used in a local dialect, but that people like aren't using as much anymore because everybody just watches TV and goes on TikTok and just like imbibes the general culture. And one of those words was logaram, which meant nonsense. It was like, oh, it's talking logaram, or like, oh, stop speaking lograms. And it comes from logarithm, like the idea of like, oh, like, well, like what's the icon of nonsense? A logarithm. Like, oh, stop talking logarithms. Like you sound like you're speaking in logarithms. So it's like a dismissive way to say someone was talking nonsense. That one I thought was a fun discovery. I remember the moment I found that, I was like, oh, that's really fun. I gotta pass that along.
Yeah, I had a question for you, but I think our conversation so far has almost answered it just in the way you've been sharing your thought process. I was going to ask you, how do you feel like mathematical thinking specifically can enrich a person's appreciation of literature or vice versa?
Yeah. I mean, what I love about math, the reason I love writing about math is it gets its tentacles in everything. It's like or tentacles is maybe a bit of a scary term. People don't want math to be a little sea monster creature that's getting its tentacles everywhere. But think of math as like maybe a river that feeds a whole landscape with these little kind of creeks and tributaries. Tributaries go in, estuaries go out, running away from the river. And so just like math, it seeps in everywhere. Which is a little different from saying, I think sometimes I'll hear people trying to preach for math, say like, math is the perspective you need for everything. It's the one true way of thinking about stuff. And like, no, that's definitely not true. But what I love about math is it fits so nicely alongside other things. It's a very purified and simplified form of thinking, but that makes it a great partner for other disciplinary perspectives. So yeah, literature. There's in my first book, I did a chapter on kind of digital humanities and like attempts to take, this is all before large language models arose, but attempts to take text and boil it down to numbers and then do stats on the numbers and then learn something about the text. And I came across, in doing that chapter, a lab, I don't know if they're still publishing new papers, I bet they are, called the Stanford Literary Language. No, that doesn't sound right. Stanford Digital Humanities Lab, something along those lines. But they had lovely papers, one where they were kind of like found a way to quantify genre, and they pulled out like the most gothic sentence they could find in any of the hundreds of novels they'd fed into the computer. And it was funny because you looked at it and you're like, oh yeah, that is the most gothic thing I've ever heard. It was like somebody walking into a creepy courtyard on an autumn moonlit night, and there were cobwebs and shadows. Like, oh yeah, this is really gothic.
Stanford
but it was sort of
Literary
interesting.
Lab.
There goes Stanford Literary Lab. Thank you. Yeah, I mumbled my way through that. Thank you, Autumn, for being my memory.
It's Google.
Yeah, well, yeah, but you're the one who summoned the genie of Google. Yeah, Stanford Literary Lab. So anyway, so stuff like that. Yeah. Oh, I'm drifting away from your good question, I think, Abe. But what does math give you as a thinker? The danger is that it makes you think of everything as quantities, right? That anything can be boiled down to numbers and then operations on numbers, and that's just not true about reality. Like much of what has made, like I had a nice day today, you can't quantify a lot of it numerically. Like I went for a run. And you can quantify how far I ran, you can quantify how fast I ran, but like the little moment when the mist kind of came off and I couldn't tell if it was raining or just water falling off of the trees from an earlier rain, that's not a 7 or something, right? That's not a 19. There's no numbers for that. So like most of what makes human life rich and exciting is not quantifiable, and that's a danger of mathematics. But the possibility of mathematics, what makes it exciting and worth everybody learning, is a thing that people don't think they like, but they do when they get to know it, the abstraction. It's the fact that math is about...
The Labor Day weekend sale is on at Tanger Outlets. Score up to 70% off at top brands like Nike Factory Store, Crocs, J. Crew Factory, Gap Outlet, and so many more. Refresh your wardrobe with the latest arrivals for less from all your favorite brands this Labor Day weekend. Tanger Outlets. Always on trend, always on sale. Plan your trip at Tanger.com.
People are driven by the search for better. But when it comes to hiring, the best way to search for a candidate isn't to search at all. Don't search, match with Indeed. The hiring process can be slow and overwhelming. Simplify hiring with Indeed. Indeed is your matching and hiring platform. With over 350 million global monthly visitors according to Indeed data, and a matching engine that helps you find quality candidates fast. Ditch the busy work. Use Indeed for scheduling, screening, and messaging so you can connect with candidates faster. Join more than 3.5 million businesses worldwide that use Indeed to hire great talent fast. Listeners of this show will get a $75 sponsored job credit to get your jobs more visibility at Indeed.com/PODKATZ12. That's Indeed.com/PODKATZ12. Terms and conditions apply.
These very abstract and very general relationships, and they give you ways, math gives you ways of conceiving of the world, of thinking about the world, is the simplest way I can put it. And that's sort of what that last section of the book is about, all those little, jokes about orthogonal and brute force. That math, because it's about very abstract relationships, it's sort of about everything, right? Like you talk about noise to signal ratio, and like that's relevant if you're transmitting something across phone lines, but it's also relevant if you're trying to figure out if a potential romantic partner is interested.
It's the empty set.
And so, yeah, there you go. Yeah, right. Yeah.
We were just having a conversation about this before jumping on the call.
Right, that's a tough one. Right, yeah. Yeah, I can't remember the exact joke I made. Right, one of the things that you get in those sorts of things is thinking about. Maybe that's my intersection joke. Is that if like someone's like, well, look, I just want an affordable place, and I want to live in walking distance of San Francisco, and it's like, yeah, that's the empty set, the intersection of those two things. Yeah,
pretty much.
Yeah.
That's exactly it.
I have a theory here. As I learn more about machine learning, I have this great idea, and then I realize it's complete nonsense, and that's happened so many times. It's been jarring, but I've gotten better at it. So I think about a really skillful comedian, any comedian at all, who can read an audience, or just one of your funny friends that can really read something. I still think there's a quantifiable measurement happening, even if we all don't share that skill set. And somehow he can anticipate things where he says the right thing at the right time, that what's the word I'm looking for, about expectations, like it subverts expectations in a way that we all find funny and delightful. I still think there's an accounting happening, and there's a measurement, and there's some kind of a skillful process, but it's more about the exchange of ideas. It still involves math, though, at least I argue.
Yeah, I think what I would say is that the lesson I take from large language models and from other generative AI is that quantification is way more powerful than I would have guessed. That just like kind of naively assigning numbers to things and throwing them into a neural network gets you much, much further than I would ever have imagined. And it can do different media, and you can do like, I played around with the music one. It's really fun. Or you feed it some lyrics and it makes a song. Like it's crazy stuff. I find it astounding what these things can do.
Yeah. Downright scary in some ways.
Yeah. Now that said, I still what it makes me think of though is there's the power in quantification, but then there's the temptation to see everything as quantifiable. And I think it doesn't actually work that way. Like the simplest example I can give is you think about the choice between, like, say you and your partner have a free night, got a babysitter, and it's like, okay, what do we want to do? Do we want to go out to see a show or something? Yes, so something kind of you go to a club. I don't know, something, I don't have to go to clubs, but something a little more.
Would you go to my club? Would you go to?
I would go to the one, with the
math lounge,
the logarithms. Oh yeah,
pour yourself a brown logarithm.
Absolutely. Well, in real life, I don't like flavorful beer, so lager is perfect for me.
Okay.
The IPAs are too much. Anyway, but so there's it's a choice between just take two, so going out, kind of having an adventurous night, or doing something really casual, going to like your favorite restaurant that's like really close by, the menu, you don't even have to look at it, like something really safe and comfortable. Which one is better, right? Like if things are quantifiable, then quantification usually starts with comparison, right? Before you can establish some kind of linear scale for things, you need inequalities, right? So like in the foundations of microeconomics, to establish what a utility function is, you sort of bootstrap it from a set of preferences. So like microeconomics, in microeconomic theory, we assume these preferences. Like hardcore utilitarians, similarly, will assume that you can rank order any experiences like that. So there should be a right answer, right? Like I, as an individual, should have a right answer. Should I go out and do the slightly more tiring thing, but a little more stimulating and novel? And down the road, I'm more likely to remember that in a year or two, like that night we did that thing, as opposed to just going to the restaurant we love and doing it again, which will probably kind of fade in memory. Like the comfort food versus the trying something new, which could go well, could not go well. Like I think genuinely there's not a right answer there. Like you can choose a preference, you can exert your will and make a choice, but it's not going to be the case that one is better than the other necessarily. Or if you on a given night do feel like one is better than the other, well, pick a different night or change the options a little bit. I think everyone can find two options where you go, well, I don't know, that one's better in some ways and worse in some ways, and like there's not a right answer as to which one is better. And like that's a very sort of like trivial thing to say in some sense, that like not all things can be compared and rank ordered. But in a world where like things are changing as fast as they are right now, a triviality like that can actually be kind of a profound thing you need to hold on to. So like it just isn't the case that everything can be, all experiences can be rank ordered, or that there's a natural quantitative scale underlying all human experience. It's like quantitative scales are great, but they're simplified models. And so it's astounding what those simplified models can do, right? Like those simplified models, as we let them get more complex and we add more dimensions, and like dimensions are great. So you keep adding dimensions to your model and you're up to like a 1,000,000-dimensional model. And it's almost starts to feel like reality. And you start thinking, well, maybe reality is just a 1,000,000,000-dimensional space. And if we can capture it all, then we'll have it all. And like, that's just not, when I think about human psychology and experience, I just don't think it is. I don't think it is a dimensional thing at all. It's something more ineffable than that. There's something more elusive. And so quantitative models can be like, are so powerful, right? Like we want to use them, but I don't want to imagine, I should say I don't want to imagine it. If that were the way it is, that's the way it is. But like looking at the world and my experience of it, I see where quantification just falls short at sort of elementary tasks.
Okay.
It's always a simplification. It's always a rounding. It's always an approximation.
Yeah, fair enough. Okay, so next question. This involves what we've been talking about, languages and, the human experience in mathematics. And this is why do you think that people often draw such a stark line between math and the humanities?
Yeah, like that line in the sand, right?
That's right.
Yeah. I mean, I think where I see it drawn most sharply is by people who really felt like they thrived in one and got really frustrated with not feeling like they thrived in the other. So, often that's people who are like successful in school in the humanities classes, and they go into math and they feel confused about it. They like can look over and see a different kid finishing the worksheets faster than they are. And it's like an alienating experience to feel like I pride myself on my success in these subjects, and then here's this one that like I can't do. So I think that's where you get like the "I'm not a math person" quote coming from, is people who like it's not actually people who like didn't like school at all. Because if you didn't like school at all, you're like, I don't know, like math was fine, English was fine, whatever. I'm glad I don't have to do it anymore. Like there's no real need to draw that distinction. It's people who actually really were invested in their academic career. People who often go into sort of professional work, white collar work, for whom like school was an important formative experience and their success in school was important for them. And that's where you have to draw the line, because if you felt like you succeeded in one and didn't feel like you succeeded in the other, it's important for you to kind of put a fence between them and say, oh yeah, but that stuff, that's different stuff. And then I think it happens less often, but also happens the other way, where people who really feel like they thrive in quantitative disciplines, the kind of reasoning and thinking and arguing and work that you do in more humanistic subjects, they may feel like, I don't know, that's always felt so fuzzy and I didn't know where I was supposed to stand. It felt like I had no firm ground underneath me. And so they will draw the line in the other way. It's like, literature, who needs it?
With that, out of curiosity, how can they use this book to help students who don't excel in math but excel in the language arts? How can they use this to help narrate that path?
Yeah, no, I appreciate that question.
Narrate.
No, right, everything is narratives. I think one of my hopes for the book is that it can become like just sort of an essential piece of equipment, a nice little guidebook for K through 5 teachers in particular, but also K through 8 teachers, of just like, here it all is in one spot. Here's like one little friendly volume that ties the ideas together, so it doesn't feel like it's this disparate collection of skills. You can kind of see the threads that will lead your students through math education. So I hope it can be equipment for them. I think like teaching needs to be done by teachers. So I never, like, in my writing about education or giving people advice about education, I try never to be like, and here's the right way to do it, because like the right way that worked for the kids I taught might not be the right way for the kids you're teaching. It's like it takes flexibility. It's an art.
Exactly.
So that's one. Yeah. So that's one hope I have for the book. And then the other one, right? You asked like what can can kids get from it? What can students get from it?
Sure.
One thing, and particularly for those English kids, you know, the sort of the proverbial English major. To me, one of the things that emerges is that math is a narrow language. It's only one lens for looking at the world. It's a very specialized language that takes some intuitions you have in childhood, you know, of like quantifying things and comparison and shape, and it shows that those seemingly kind of simple intuitions can bring you to really fabulous places. But I guess I would take away that like math isn't everything. There are things that are beyond the purview of math. And so, yeah, and I think the sense of the scope of math, what is math for and not for? What does it do for us and what does it not do for us? I think to make it approachable, it's important to acknowledge like math doesn't do everything. It's like it's not no tool does everything. What math does is astounding. But it's got its place on the shelf, and I think that can make it seem less like this amorphous entire worldview that you haven't adopted or something, even though it sort of is a whole worldview. But we all have lots of worldviews that we can switch between, and math is one worth having.
Let me ask you this. Going back to my analogy earlier where I talked about RPG skill trees, obviously this book, both the ability to do mathematics, to understand mathematics, and to communicate mathematics, those are all different skills. I've had teachers that were brilliant mathematicians but could not communicate and relied on a script that was prepared from other people to write on the chalkboard line by line. They couldn't explain their thinking. Now, all that said, how would you rank, or how would you describe your own artistic ability or creativity versus your mathematics? I've got an answer too, but I'd like to hear that from you.
Oh, you have an answer for yourself and an answer for me?
I have an answer for myself, absolutely. I'll share it. I'd like to share it, but I could share it first as a for example, perhaps.
Either way, yeah. Yeah.
Sure, yeah. I'll go and share first. So actually, I am very, very much an artist, like literally an artist and a painter and a storyteller who learned how to do mathematics and the slow process of learning it. Once I got it, I feel like I got it pretty well. But I was always slower in math until I made it through engineering school. And one day, I kind of felt like I had a shift in how I was thinking, and I had to experience that. It was uncomfortable, but when I got it, and I understood it, and I knew what to expect, I feel like I did pretty well. So now I feel like I've got natural skills in creativity and hard work and earned skills in mathematical modeling and learning how to calculate and think about things analytically, which is very different than creatively.
Yeah, that's interesting. Yeah, I'm curious to hear yours too, Autumn. But yeah, my own skill tree, I think I'm definitely not a hands-on person. I will put it that way. Like I'm very comfortable with ideas and navigating spaces of ideas. That's where I love to live. And like drawing a picture on a piece of paper, that's tough. That's hard work. That's why it was math with bad drawings was the way I began, and why that's still kind of my brand and who I am. Yeah. That is the simplest way to put my own skill set. Math didn't ever feel as separate from other subjects to me as it felt to other people. I think math fit in very naturally for me among other academic subjects, and I think you see that in my writing, that like I move between them quite fluidly in a way that someone who's a more singular advocate for math might not.
Okay.
But yeah, where I've always seen it tempered in myself of like, I'll be like trying to help my daughter, my 5-year-old, with crafts, and like just like getting the needle through the thing, getting the glue to stick to the thing. It's like element, like stuff that a reasonably competent 8-year-old can do. That's about my level. Yeah. I'm like not unathletic. I'm reasonably coordinated when it comes to sports, but like a little fine motor, I don't know, making the finicky stuff work, I've always been very, very bad at.
But your gift of gab is on point. I mean that in the best way, like your ability to speak captivatingly. And again, there are mathematicians who don't have that. And what's actually really astonished me, and you know what? Before I continue, we got a sign that said we've got 2 minutes left in studio. So I'll be quick here. I also want to hear, Autumn, your answer to this as well. I'm going to make time for you as well. Reading the autobiography of Oppenheimer, and I forgot what the book was called, American Prometheus, I believe. He talked explicitly how in Los Alamos Labs, among all the busy physicists, Richard Feynman and Niels Bohr, when he was there, or just other physicists, there are idea people, and there are engineer people. There are, as they called it, the brick makers and the brick layers, and they're very different. Oppenheimer was an idea person. He was not a hands-on person. Okay, there's Lawrence Livermore Labs. There are physicists who that lab is named after. He was the engineer. He was the one that made the cyclotron. Like very much hands-on. Yeah. So I find that even among, geniuses, there's different types, different tools. All right. And I'd love to hear your skill tree discussion, Autumn, if I may.
I'm actually very skilled as an origamist.
Interesting.
And yeah, so I can do the intricate folds for all of the mathematics. I can see how things are built structurally. And I'm also what the people listening to the podcast don't see is I am a very talented artist.
Yes, you are. You absolutely are.
So
I like that I'm easily the worst artist on this call here on this podcast.
But here's the thing. I can build whatever engine it is or whatever structure. If you ask me a technicality and a proof, nope, I'm gone. Throw it out the window.
Interesting.
It's polar opposite. So I can build you the whole concept, tell you how to write it, but sometimes the technicalities of things, but I don't care.
Interesting.
I'm the person that makes sure that it works.
Yeah, I know this is a bit of a strange topic, and I don't want to get too much into it because I don't want to get too much into comparison here. But you when you read about Albert Einstein, for example, and you read about his 1 year, there's a term for the year that he published those 4 papers. What was that?
Yeah, the Annus Mirabilis,
okay.
Miracle Year.
Yeah, you can read it, and you get these brilliant physicists who read it and say, this guy was the smartest man that ever lived to see these connections. But then you get into the less popular mathematicians like Enrico Fermi. Or Pauli. I'm sorry. There's Pauli. There's Fermi. There's Dirac. There's these names that unless you're a physicist, you may not hear. And you see the way they did their math. And I would say they were much more powerful mathematicians than Einstein. They ran circles around Einstein, but I wouldn't say that they saw the connections in different fields the same way, if that makes sense. So again,
thing, Gabe,
yeah.
Just a little thing.
Sure.
When Einstein published all of his papers, those were considered his golden years. Do you know why?
Why?
Because his wife was the one who wrote a lot of it.
Oh, man. Okay. That's awesome.
Every great man is an exceptional woman.
Absolutely. Yes.
Yeah, in their divorce proceedings, I want to say, I think I remember that it's in the Isaacson biography. Some part of the condition in the divorce was sort of when he wins the Nobel, she got the bulk of the money or something like that.
Yeah.
That was part of their agreement for the divorce.
Oh my gosh.
Yeah, which I'm not sure. I don't think that was specifically about credit or something. But,
that's like
she couldn't take the courses, and the university wouldn't allow her to sit in the classes for such a long time.
Wow.
So she wrote all of the papers and everything.
Yeah. Wow.
And that's where like 80% of the stuff is.
Yeah, and I'm sorry to end it here, but the studio needs to kick me out because I'm just borrowing their studio here. But Ben, it's been too long, and it's been an absolute pleasure. Because I'm very busy, I give full reign to Autumn. Autumn, if you ever want to have Ben on again for any reason and any episode, please do so. Just give him a call, get him on.
That'd be great. No, I'd love it.
Yeah,
awesome.
Absolutely.
Let's take full advantage. And Autumn, I don't say thank you to you specifically enough. You take the reins and you make this show what it is. It couldn't be what it is without you. So thank you so much. And I mean that. And all the work you put into putting this episode together, you put the outline together, you are editing everything. Behind every great man is a great woman. So thank you so much.
Oh, it's too bad.
Yeah. Sorry, no, it's true. I get it,
Yeah. No. And thank you both, Autumn and Gabe. It's fun chatting with you both. And I admire the work both of you are doing with the podcast and with the Breaking Math Empire.
Awesome.
The Labor Day weekend sale is on at Tanger Outlets. Score up to 70% off at top brands like Nike Factory Store, Crocs, J. Crew Factory, Gap Outlet, and so many more. Refresh your wardrobe with the latest arrivals for less from all your favorite brands this Labor Day weekend. Tanger Outlets, always on trend, always on sale. Plan your trip at Tanger.com.